together with teacher Francisca, who would like to share on the topic acid, bases, and salts. The subtopic for acid, base, and salt include the role of water in showing acidic and alkaline properties, pH value, strength of acid and alkalis, chemical properties of aqueous solution, concentration of aqueous solution, standard solution, neutralization, salt crystals and their uses in daily life, preparation of salts, effect of heat on salts, and qualitative analysis. What are acids? According to Swedish chemist Arrhenius proposed definition for acid. An acid is a substance which ionizes or dissociates in water to produce hydrogen ions. When acid is dissolved in water, the hydrogen atoms in acid molecules are released in the form of hydrogen ions. Example, hydrogen chloride gas dissolved in water. Hydrogen chloride molecules will ionize in water to produce hydrogen ions and chloride ions. Hydrogen ions will combine with the water molecules to form hydrosonium ions. The equation, hydrogen chloride gas reacts with water and ionize to produce hydrosonium ions and chloride ions. Next, we go to basicity of acid. Basicity of acid refers to number of hydrogen ions that can be produced by an acid molecule that ionizes in water. Basicity of acid can be classified into monoprotic acid, diprotic acid, and triprotic acid. Monoprotic acid is an acid contains one ionizable hydrogen atom, producing one hydrogen ion per acid molecule. Example, hydrochloric acid, HCl, nitric acid, HNO3. Diprotic acid is an acid contains two ionizable hydrogen atoms, producing two hydrogen ions per acid molecule. Example, sulphuric acid, H2SO4. Triprotic acid is an acid contains three ionizable hydrogen atoms, producing three hydrogen ions per acid molecule. Example, phosphoric acid, H3PO4. What is base? A base is a substance that reacts with acid, hydrochloric acid, nitric acid, and sulphuric acid to produce salt and water only. Example of base, metal oxide, zinc oxide, copper 2 oxide, sodium oxide, and potassium oxide. Metal hydroxide, zinc hydroxide, copper 2 hydroxide, sodium hydroxide, and potassium hydroxide. What is an alkali? Alkali is a base that is soluble in water and ionizes to produce hydroxide ions. Example, potassium hydroxide KOH, sodium hydroxide NaOH, and ammonia aqueous NH3. Next, we go to the role of water to show acidity and alkalinity. An acid only shows its acidic properties when dissolved in water. When an acid is dissolved in water, acid molecules will ionize to produce hydrogen ion. Presence of hydrogen ion causes the acid to show its acidic properties. The diagram shows hydrogen chloride dissolved in two different solvents, water and methyl benzene. Hydrogen chloride gas in water ionized. Hydrogen ions and chloride ion present shows acidic properties. However, hydrogen chloride gas does not ionize in methyl benzene. No hydrogen ions and chloride ions present exist as molecule, does not show acidic properties. Alkalis only shows alkaline properties when they are dissolved in water. Water helps the ions or molecules to ionize to produce hydroxide ion. Presence of hydroxide ion causes the alkali to show its alkaline properties. Question 1. Table 1 shows the apparatus setup and observations of two sets of experiments. The aim of the experiment is to study the electrical conductivity and one property of acid when hydrogen chloride is dissolved in solvent X and solvent Y. For set 1, in picture 1, hydrogen chloride in solvent X. The observation is the bulb lights out. In picture 2, hydrogen chloride in solvent Y. The observation is the bulb does not light out. For set 2, in picture 1, reaction between hydrogen chloride in solvent X with calcium carbonate. The observation is colorless gas releases and lime water turns cloudy. In picture 2, reaction between hydrogen chloride in solvent Y and calcium carbonate. The observation is no change.
Based on table 1, suggest solvent X and solvent Y.
In picture 1, hydrogen chloride in solvent X. The bulb lights out. Therefore, solvent X is water. In picture 2, hydrogen chloride in solvent Y. The bulb does not light out. Therefore, solvent Y is an organic solvent. Example, methyl benzene or propanol or any other suitable organic solvent.
Explain the differences in the observations for both sets of experiments.
For set 1, it is shown that hydrogen chloride in solvent X can conduct electricity. There are free-moving ions present. Hydrogen chloride ionizes in water. However, hydrogen chloride in solvent Y cannot conduct electricity. Hydrogen chloride exists as molecules, no free-moving ions present, and hydrogen chloride cannot ionize. For set 2, it is shown that hydrogen chloride in solvent X, carbon dioxide gas is produced. There is a presence of hydrogen ions. Therefore, hydrogen chloride in solvent X show acidic properties. However, hydrogen chloride in solvent Y, no carbon dioxide gas produced, no hydrogen ion present. Therefore, hydrogen chloride in solvent Y cannot show acidic properties.
Write 1 chemical equations involved.
To write a chemical equation, first, correct formula of reactants and products. Second, balance the equation. 2HCl reacts with CaCO3 to produce CaCl2 and CO2 and H2O. Next, we go to the relationship between pH values and the concentration of hydrogen ions. When the concentration of acid increases, more acid molecules ionize to produce hydrogen ions. The higher the concentration of hydrogen ions, the lower the pH value. Acidity increases when the pH value of the acid solution decreases. Relationship between pH values and the concentration of hydroxide ions. The higher the concentration of hydroxide ions, the higher the pH value. Alkalinity increases when the pH value of the alkaline solution increases. Strength of acid. Strong acid. A strong acid is an acid which ionizes or dissociates completely in water to produce a high concentration of hydrogen ions. Example, hydrochloric acid HCl, nitric acid HNO3, and sulphuric acid H2SO4. Weak acid. A weak acid is an acid which ionizes partially in water to produce a low concentration of hydrogen ions. Example, ethanoic acid CH3COOH. Strength of alkalis. Strong alkali. Strong alkali is an alkali that ionizes completely in water to produce a high concentration of hydroxide ions. Example, sodium hydroxide NaOH, potassium hydroxide KOH. Weak alkali. Weak alkali is an alkali that ionizes partially in water to produce a low concentration of hydroxide ions. Example, ammonia solution NH3. Question 2. Diagram 2.1 and diagram 2.2 shows the pH value of the acid HA and HB. Both are monoprotic acid. In diagram 2.1, HA acid in water, pH value 1. In diagram 2.2, HB acid in water, pH value 4.
Suggest the names of HA acid and HB acid.
HA acid in water in diagram 2.1. Acid ionizes completely in water to produce high concentration of hydrogen ion. HA acid is strong acid. The name for HA acid is hydrochloric acid or nitric acid. HB acid in water in diagram 2.2. Acid ionizes partially in water to produce low concentration of hydrogen ion. HB acid is weak acid. The name for HB acid is ethanoic acid.
Explain why the pH values of the two acids are different.
HA acid is strong acid, but HB acid is a weak acid. HA acid ionizes completely in water, but HB acid ionizes partially in water. HA acid produces high concentration of hydrogen ions, but HB acid produces low concentration of hydrogen ions. The higher the concentration of hydrogen ion, the lower the pH value. Next, we go to standard solutions. What is a standard solution? A standard solution is a solution with known concentration. Two parameters that have to be measured accurately: mass of the solute and volume of distilled water. During dilution, water that is added to the aqueous solution will alter the concentration of the solution, but it will not alter the number of moles of solute contained in the solution. Number of moles of solute before dilution equal to number of moles of solute after dilution. N1 equal to N2, therefore M1V1 equal to M2V2. Where M1 is the molarity of solution, stock solution before dilution. V1 is the volume of solution, stock solution before dilution. M2 is the molarity of solution, prepared solution after dilution. V2 is the volume of solution, prepared solution after dilution. Question 3. The information below shows a list of apparatus and chemical substances that can be used to prepare sulphuric acid solution through dilution method from a stock solution. The stock solution: 2 molar sulphuric acid, pipette, volumetric flask, and distilled water.
Calculate the volume of the stock solution needed to prepare 250 cm3 of 0.2 molar of sulphuric acid.
Given M1 is 2 molar, M2 is 0.2 molar, V1 volume of the stock solution needed, V2 is 250 cm3. Using the dilution formula, M1V1 equal to M2V2, so V1 is equal to 0.2 times 250 divided with 2. The answer, 25 cm3.
Describe briefly the steps taken to prepare the solutions in A1 by using the apparatus listed.
First, pipette 25 cm3 of 2 molar sulphuric acid. Second, transfer into a volumetric flask 250 cm3. Number 3, add distilled water until it reaches graduation or calibration mark. Next, we go to neutralization. What is a neutralization? Neutralization is a reaction between an acid and a base to produce salt and water. Salt and water produced are neutral. Equation: acid and alkali to produce salt and water. Titration method. Titration method is a quantitative analysis method used to determine the volume of an acid needed to completely neutralize a given volume of alkali and vice versa. In acid-base titration, a solution of known concentration is slowly added from a burette into a conical flask that contains a volume of alkali of unknown concentration. Titration stops when the acid-base indicator changes color. Endpoint: Endpoint is the point in the titration at which the acid-base indicator changes color. Common acid-base indicators are litmus solution, color in acidic solution red, color in neutral solution purple, color in alkaline solution blue, methyl orange, color in acidic solution red, color in neutral solution orange, color in alkaline solution yellow, phenolphthalein, color in acidic solution colorless, color in neutral solution colorless, color in alkaline solution pink. Universal indicator solution, color in acidic solution red, orange or yellow, color in neutral solution green, color in alkaline solution purple. Question 4. Diagram 4 shows the apparatus set up to determine the endpoints of titration for the neutralization reaction between 0.2 molar sulphuric acid with 25 cm³ potassium hydroxide solution. Phenolphthalein indicator is added into the conical flask containing potassium hydroxide solution.
What is the color change of the solutions in the conical flask at the endpoint?
At the endpoint, color change from pink to colorless. The result of the experiment is recorded in Table 4. Titration 1. Final B rate reading 20.00. Initial B rate reading 7.60. Volume of sulphuric acid used. Final B rate reading minus the initial B rate reading 12.40. Titration 2. Final B rate reading 32.50. Initial B rate reading 20.00. Volume of sulphuric acid used 32.50 minus 20.00, 12.50. Titration 3. Final B rate reading 37.60. Initial B rate reading 25.00. Volume of sulphuric acid used 37.60 minus 25.00, 12.60. Reaction between sulphuric acid and potassium hydroxide solution is represented by the following chemical equation. Sulphuric acid H2SO4 reacts with 2 potassium hydroxide KOH to produce potassium sulfate K2SO4 and 2 water H2O.
Calculate the average volume of sulphuric acid used for the neutralization reaction. Then, calculate the concentration of potassium hydroxide solutions used.
The average volume of sulphuric acid used is 12.4 plus 12.5 plus 12.6 divided by 3 equal to 12.50 cm³. Then, find the ratio of moles. 2 mole of potassium hydroxide react with 1 mole of sulphuric acid, or 0.005 mole of potassium hydroxide reacts with 0.0025 sulphuric acid. Molarity of potassium hydroxide is 2 times 0.2 times 12.5 divided by 25 equal to 0.2 molar.
If the sulphuric acid is replaced with nitric acid 0.2 molar, predict the volume of nitric acid that will be used to neutralize the potassium hydroxide solution. Explain your answer.
If sulphuric acid is replaced by nitric acid, the volume of nitric acid that will be used to neutralize the potassium hydroxide solution is 25 centimeter cubic, or double, or twice. It is because sulphuric acid is diprotic acid and nitric acid is monoprotic acid. The concentration of hydrogen ion or number of hydrogen ions per unit volume in sulphuric acid is twice. Question 5. A farmer discovers that his vegetables are not growing well due to soil problems.
By using your chemistry knowledge, state 2 possible causes and ways to overcome the problems by naming the chemical used.
The possible cause due to acidic soil. Where to overcome? Add calcium oxide. Another possible cause due to alkaline soil. Where to overcome? Add sulfur or iron to sulfate. Another possible cause due to lack of nutrient or fertilizer. Where to overcome? Add urea or ammonium nitrate. Next we go to salt. What is salt? Salt is an ionic compound produced from neutralization reaction between acid and alkali. Salt is an ionic compound formed when the hydrogen ions from the acid is replaced with the metal ion or the ammonium ion. Type of salts. Insoluble salt. Salt that undissolved in water at room temperature. Soluble salt. Salt that dissolve in water at room temperature. Before preparing the salt, we must know whether the salt is soluble or insoluble. It is because soluble or insoluble salt have different methods to prepare the salt. The table shows the type of salts and solubility in water. Sodium ion, potassium ion, and ammonium salt all are soluble. Nitrate salt all are soluble. Chloride salt all are soluble except lead 2 chloride, silver chloride, mercury chloride. Sulfate salt all are soluble except lead 2 sulfate, barium sulfate, and calcium sulfate. Carbonate salts all are insoluble except sodium carbonate salt, potassium carbonate salt, and ammonium carbonate salt. Salt preparation. Solubility of salt, soluble and insoluble. For the soluble, sodium ion, potassium ion, and ammonium ion. We use acid and alkali neutralization, not salts of sodium ion, potassium ion, and ammonium ion. Reaction between acid and metal, acid and metal carbonate, acid and metal oxide. For the insoluble salt, we use double decomposition reaction or precipitation. Heating of carbonate and nitrate salt. The color change of the residue after the heating of carbonate salts. Lead 2 carbonate is white. Lead 2 carbonate decomposes to produce lead 2 oxide and carbon dioxide gas. Lead 2 nitrate. decompose to produce lead-2 oxide and nitrogen dioxide and oxygen gas. Lead-2 oxide is brown when hot, yellow when cool. Zinc carbonate is white. Zinc carbonate decomposes to produce zinc oxide and carbon dioxide. Zinc oxide is yellow when hot, white when cool. Copper 2 carbonate is green. Copper 2 carbonate decomposes to produce copper 2 oxide and carbon dioxide. Copper 2 oxide is black. Magnesium carbonate is white. Magnesium carbonate decomposes to produce magnesium oxide and carbon dioxide. Magnesium oxide is white. Sodium carbonate is white. Sodium carbonate does not decompose, does not produce carbon dioxide. Metal carbonate of group 1 elements do not decompose by heat. Sodium carbonate, lithium carbonate, and potassium carbonate. Question 6. Diagram 6 shows a flow chart of zinc salt. All the 3 salts, zinc sulfate, zinc chloride, and zinc nitrate in diagram can converted to zinc carbonate by reaction 1. Then, zinc carbonate reacts with acid W to form zinc salt through reaction 2.
By choosing one of the 3 salts in diagram, suggest solutions R to prepare zinc carbonate.
To prepare zinc carbonate salt, ZnCO3, which is an insoluble salt, solution R must be soluble carbonate salt. Therefore, solution R is sodium carbonate, Na2CO3, or potassium carbonate, K2CO3, or ammonium carbonate, NH4-2CO3.
Write the chemical equations involved.
To write a chemical equation, correct chemical formula of reactants and products. Then balance the equation. Zinc sulfate ZnSO4 reacts with sodium carbonate Na2CO3 to produce zinc carbonate ZnCO3 and sodium sulfate Na2SO4.
Describe a laboratory experiment to prepare the salt.
Zinc carbonate ZnCO3 is an insoluble salt. Insoluble salt can be prepared through double decomposition reaction. 2 salt solutions that contain insoluble salt ions are needed. Example, zinc carbonate, aqueous solution containing zinc ion. Aqueous solution containing carbonate ions. To prepare zinc carbonate salt, ZnCO3, first, 20 to 100 cm cubic of 0.1 to 2 molar zinc sulfate solution is measured and poured into a beaker. Second, 20 to 100 cm cubic of 0.1 to 2 molar sodium carbonate solution or potassium carbonate solution or ammonium carbonate solution is measured and poured into the beaker. Number 3, stir the mixture. Number 4, filter the mixture. And finally, rinse. Then you zinc carbonate salt.
Suggest acid W to prepare any one of the three zinc salts in diagram.
To prepare soluble zinc sulfate salt, ZnSO4, acid W is sulphuric acid. To prepare soluble zinc chloride salt, ZnCl2, acid W is hydrochloric acid. To prepare soluble zinc nitrate salt, ZnNO3 bracket 2, acid W is nitric acid.
Write a chemical equations involved.
To write a chemical equation, correct chemical formula of reactants and products, then balance the equation. Zinc carbonate ZnCO3 reacts with 2 hydrochloric acid HCl to produce ZnCl2 plus CO2 plus H2O.
Describe a laboratory experiment to prepare the salt.
To prepare the soluble salt, reaction between acid and reactive metal to produce salt and hydrogen gas. Acid and metal oxide to produce salt and water. Acid and metal carbonate to produce salt and carbon dioxide and water. To prepare zinc chloride salt, ZnCl2, first, 20 to 100 cm cubic of 0.1 to 2 molar hydrochloric acid is measured and poured into beaker. Second, 8 zinc carbonate into acid until excess. Number 3, stir and filter. Number 4, heat until it's saturated or 1/3 of original solution. Number 5, cool and filter. Using the same procedure, try to prepare zinc sulfate salt and zinc nitrate salt. Question 7. Diagram 7 shows the conversion of solid W to solution Y and solid Z. Analysis on solution Y is done to identify its cation and anion. Green solid W reacts with acid X to produce blue solution Y and gas V and water. Green solid W, when heated, black solid Z is formed and gas UV is released. Blue solution Y reacts with nitric acid, silver nitrate, white precipitate is formed. Blue solution Y reacts with reagent J. Blue precipitate soluble in excess region J to form dark blue solution.
Based on diagram 7, identify substance G, V, W, X, Y, and Z.
Based on diagram 7, green solid W is copper 2 carbonate. Blue solution Y contains copper 2 ion. For the anion test, blue solution Y added with nitric acid followed by silver nitrate. White precipitate is formed. Confirm chloride ion is present. For the cation test, blue solution Y added with reagent J. blue precipitate soluble in excess reagent J to form dark blue solution. Confirm copper to ion is present. Therefore, reagent J is ammonia solution and blue solution Y is copper to chloride. Acid X is hydrochloric acid. Gas UV is carbon dioxide. When green solid W is heated, black solid Z is formed. Black solid Z is copper to oxide.
Solid W react with acid X to produce solutions Y, gas V, and water. Write the chemical equations for the reaction and describe a chemical test for gas V.
To write a chemical equation, correct formula for reactants and products, then balance the equation. Copper to carbonate CuCl3 reacts with 2 hydrochloric acid HCl to produce copper to chloride CuCl2 and carbon dioxide CO2 and water H2O. Describe a test for gas V, correct method, chemical and observation. Flow or channel or pass the gas into lime water. The lime water turns chalky, cloudy, or milky. Question X. Diagram 8 shows the reaction scheme for lead to carbonate. Lead to carbonate reacts with nitric acid to produce salt X, gas Y, and water. Gas Y turns water chalky.
Based on diagram 8, identify salt X and gas Y.
Salt X is lead to nitrate. Gas Y is carbon dioxide.
Describe briefly chemical tests to verify the cation and anion in X solution.
Salt X is lead to nitrate. Lead to nitrate consists of lead to ion, the cation, and nitrate ion, the anion. Chemical test for cation, lead to ion. First, add potassium iodide or sodium iodide solution. The observation is yellow precipitate formed. Chemical test for anion, nitrate ion. First, add dilute sulphuric acid, iron to sulfate solution. Second, slowly add concentrated sulphuric acid. The observation is brown ring is formed.
In an experiment, excess lead to carbonate is added into 100 cm3 of 1 molar of nitric acid. Write the chemical equations for the reaction and calculate the volume of gas Y produced at room conditions. Given 1 mole of any gas occupies 24 decimeter cubic at room condition.
To write a chemical equation for the reaction, first, correct chemical formula of reactants and products. Second, balance the equation. Lead to carbonate PbCO3 reacts with 2 nitric acid HNO3 to produce lead to nitrate PbNO3 bracket 2 and carbon dioxide CO2 and water H2O. To calculate the volume of gas Y, carbon dioxide gas, first, calculate the number of mole of acid. Second, mole ratio. Third, volume of gas with unit. mole of nitric acid equal to mv over 1000. 1 times 100 divided by 1000 equal to 0.1 mole. 2 mole of nitric acid produce 1 mole of carbon dioxide gas. Mole carbon dioxide gas equal to 0.05 mole. Therefore, volume of carbon dioxide gas is 0.05 times 24 decimeter cubic or 1.2 decimeter cubic or 1200 centimeter cubic.
X can be converted back to lead-2 carbonate through reactions W. Suggest a suitable chemical substance that can be used to convert X to lead-2 carbonate. State the name of reactions W. State the observation and include an ionic equation in your answer.
Suitable chemical substance that can be used to convert X to lead-2 carbonate is sodium carbonate or potassium carbonate or ammonium carbonate. The name of reaction W is carbon decomposition or precipitation reaction or method. The observation is the white precipitate is formed. Ionic equation lead-2 ion react with carbonate ion to produce lead-2 carbonate.
Based on diagram 8, compare and contrast the observations for lead-2 carbonate and solid X when both compounds are heated separately.
This is the heating of lead-2 carbonate, produce Z and gas Y. Salt X also heated to produce Z and oxygen gas and nitrogen dioxide gas. When both lead-2 carbonate and solid X are heated separately, both compounds decompose to produce lead-2 oxide. Therefore, Z is lead-2 oxide. Similarity. Observation for lead-2 oxide. The color of residue remains brown when it is hot and yellow when it is cold. Gas Y is produced when lead-2 carbonate is heated. Oxygen gas and nitrogen dioxide gas is produced when salt X is heated. The differences in observation. For lead-2 carbonate, gas Y is carbon dioxide. Therefore, the observation is the gas turns lime water chalky. For solid X, oxygen gas and nitrogen dioxide gas is produced. Therefore, the observation is glowing wooden splinter rekindles or brown color gas produced. Question 9. Diagram 9 shows a beaker containing a mixture of two solid salts given to students in a school laboratory. Mixture of lead-2 chloride and lead-2 nitrate.
Describe briefly how both salts can be separated.
It is based on the solubility of the salt. Lead-2 chloride is an insoluble salt. Lead-2 nitrate is soluble salt. To separate the mixture of two salts, first add distilled water into the mixture and stir. Second, filter. Finally, rinse. Then you can separate the mixture of the two salts. That's all from our sharing. All the best for your SPM. Thank you.